Hey everyone, thanks for joining us for our unPAC office building series. We are now live with Aaron Levy. He is going to be our one-stop shop for everything Q-PAC again today. He's going to be providing you some applications, ideas, solutions, and challenges specifically around office buildings. In the chat today, we have Mo Afshin. He is our other product engineer and application engineer. He'll be answering the questions. So if you have any questions, please feel free to put them in the chat. I'll interrupt Aaron, or Mo is going to be able to provide you some other insights in the chat. We are going to dive right in today. We're going to announce our Q-PAC Summit. So unPAC Summit is October 18th and 19th. We still have a few spots left. We'd be excited to have you down in St. Augustine this fall. That's going to be in a couple weeks. We're going to do everything from product demos to talks with keynote speakers. We're going to have networking events, and we are building a customized experience for every person who attends. And we're really excited to have you all down there. So that is in the works, and that will be launching very soon. And I will turn everything over to Aaron. Again, if you have any questions, please put it in the chat for Mo and I. If you have any questions outside of that or want to maintain contact with us, that marketing@qpac.com email that's at the top of your screen, that's going to be the best way to reach out to me directly, and I will get you in touch with one of our engineers moving forward. So after that, Aaron, please take the stage.
All right. Well, you'll give me the next slide. Let's see if you'll... So today we're going to talk about office buildings. If anybody has been on the last couple of unPACs or unPAC series, where we went over universities and hospitals, very similar flow and things we'll go over with another little couple of added options that go along with it. We're going to start talking about application demands as we go into it. So if you'll hit the next one for me. And then the next one. Technology is great when it works, everyone. So with office buildings, very similar to any other kind of building that we've talked about before, typically have a wide range of static pressure demands. A lot of them somewhere to anywhere from 1.5 to 7 inches on the supply side. Returns can vary. And they'll have a variety of floor plans and constructions. A lot of challenges that we'll face are multi-floor HVAC systems where one unit controls, anywhere from 2 floors to maybe 14. So you end up having these big blowers, tight hallways and access points, even rooftop air handlers. So sometimes you'll get them on the rooftops of these big, tall buildings. So if they wanted to replace that unit as a whole, they need cranes or something like that. And then changes from the original design as these buildings are sometimes over 15, 20, 30 years old. The original existing ductwork and everything has probably been altered. Rooms have probably been altered. Things to consider when you're looking at going from an engineering schedule to what is existing today. Next one for me. And a lot of the maintenance, we always say, where does it end? When you're looking at a lot of old existing systems with belt drives, direct drive plenum fans, vane axials, things like that, where they've got direct drive motors or belts or pulleys, there's always some kind of servicing that needs to be done, bearings to be greased, belts to be changed, motor tension bases need to be adjusted on the regular. These things eat up a lot of maintenance time. It also causes points of failure, which if they don't have any redundancy, like many of these systems don't have, they do end up having to be down for a significant period of time until either an on-site crew can fix it or get somebody in from an outside source to come in and fix it. So definitely something that they need to consider when they're looking at doing retrofit type applications to limit their downtime going forward in a post-installation service. So next, and just if you've walked around any of these older buildings, they never were really designed with the maintenance crew in mind of having to get access to these systems. You've seen tight hallways over and under different things, around pieces of equipment, and having to do some of that stuff when you're talking about retrofitting something out or adding something new in, either recalls cutting holes in the side of the building, moving a whole bunch of equipment, and it had a lot of engineering challenges on not just the rep side or the design side from the engineering side, but also from the mechanical contractor side, which can add a lot of cost and labor to it. The Q-PAC system is always been designed to be hand carryable into spaces, up stairwells, around corners. So you don't really have some of the woes of trying to replace shafts and motors and things like that that are really long, big, and heavy. the heaviest component on our system tends to be the fan. And that system tends to be about less than 150 pounds. So in most cases, a 2-person team can carry those things in, which makes getting access to those areas really easy with the Q-PAC system. Next. And when we talk about aging equipment, this is stuff that you see pretty regularly: double width, double inlet blowers, belt drive systems with pillow block bearings. Some of them still have, in 90% of the cases, probably non-working inlet guide vanes. So all this stuff that is broken over the years that nobody either wants to fix or doesn't really add any value to their system is just still there, rusting and getting older, and all the efficiency they're losing. And what they face with these challenges is that a lot of these occupants are in the building, most of the business day, and the only time they really ever have downtime is either in the evenings or on the weekends. So a Q-PAC system can be installed normally, depending on the size of it, in less than 8 hours after demo. So normally, like, they'll shut down Friday night, start demoing it, be ready to install it on Saturday evening, and then by Sunday morning they're up and running, ready for the occupants to come in on Monday, where they've been none the wiser that equipment's been serviced. A lot of older buildings, again, when we talk to having multiple floors, they're often in places that are difficult to service, and they have motors that are 75 horsepower and higher. Especially when you're doing, anywhere from 5 to 10 floors of a building, you can get anywhere from a 75 to a 250 horsepower motor, and those things can weigh anywhere from 1,000 to 3,000 pounds. And having to replace one of those from a maintenance standpoint is incredibly difficult, because you've either got to crane it into a place, because you're not just a team's just not carrying that up on a pallet up to the space. And then, of course, your preventive maintenance challenges that are pinch points for later. You eliminate all that bearings, eliminate all the belts and pulleys, saves them not just having the maintenance costs, but adding the redundancy into their system will allow them to have a little peace of mind later on, is if something does fail, that nobody panics when there is something, because the system is designed well enough to be able to carry the load until a time could be shut down safely and replace it. Next up for me. And one of the things that a lot of us face on this side of the building side is the engineering challenges between what was designed on a system and what the actual reality of the system is. A lot of these the systems were designed 10, 15, 20 years ago on a piece of paper. A lot of these engineers, and there's nothing against the architect or anybody else, when they're designing a building, they're doing load calculations on CFM, static pressure, or square footage versus how much tonnage you need, and then extrapolating it out. Can't really miss a target, because you don't want to under design a system, so they tend to over design a system. And a lot of those things will come out when we talk about retrofitting. Either the on-site building has never done any test and balancing, and they don't have test and balancing reports from however long it's been. So when a team walks in, they say, well, we're going to retrofit the system. Here's our engineering print, and it's 50, 60,000 CFM at 9 inches of static. The actual reality is that system's probably not running anywhere near that. And if we can design around the building schedule, but I always tell people, like in this instance here, it can make a big difference in your electrical. It can make a big difference in the cost of the system up front, because we can remove a fan in most cases. And normally when you start getting above 45 to 50,000 CFM on a schedule, it starts to behoove the customer to have that system tested and balanced. For a few $1,000s to have that system, to get an idea of what the system's actually running versus what's written down on a piece of paper, can save them 2 or 3 fans in the grand scheme of a system, especially the higher you go up. So in essence, the test and balance will normally pay for itself if they do that by having to be able to design a system that's more geared for what they actually have versus what they think they have. So I do encourage that conversation, mainly because the electrical service that's there will be existing for whatever it was. There's no point putting, if the system's running at 25,000 CFM, there's no sense designing it to run 45, 50,000 CFM. It seems a big excess. The chances are they'll never use all that stuff, and they end up paying for more equipment than they need on the front side, which makes the job much more competitive and expensive than it needs to be. So something to consider when you're looking out there is working that price of a test and balance system into the quote to give them a better design of what they need. I can always plan 10-20% of overhead more than what there actually is if they feel like they need a safety factor. But proving that to them on paper will make their lives a lot easier, and making sure they don't spend too much money on the front side and that they're not wasting money on the back side. And this is something that we talk about with Q-PAC being, the way it was designed and the way it's engineered is that we have that built-in redundancy. If a fan does fail, the rest of the fans in the system will spool up to compensate for that lost fan. It takes about 10 or 15 minutes to change out a fan. So they're never really down for very long. In most cases, the occupants would even know, even if you didn't have an N+1 system and your system is designed at maybe 80 to 90%. In a lot of cases, your system probably won't notice the slight loss in air performance, and your occupants probably won't notice the slight air loss performance until the end of the day, where they can switch that fan out and continue on, and then they're back up and running, none the wiser. Building continuity is always a big thing. Being able to have 1 or 2 part numbers over the entire range of the building will make their lives a lot easier versus having 5 or 6, 7 different size motors from 1 horsepower to 5 to 7.5 to another 10 or 15s. Numerous belt sizes they may need to carry, different pulleys. All of this stuff can really make a building just that much more difficult to maintain and operate because of all the different parts that you may need to keep on hand. If there's a building with any significant amount of air conditioning in their system with belt drive systems, I guarantee there's a maintenance shop somewhere in that facility with a wall of belts on it, like you saw in the picture a few slides ago. It just makes their lives easier to say, I have 2 fan models that'll contain my entire building, and this fan goes to these 30 air handlers, and this fan goes to this 5. So they have fewer parts to keep on hand. And one of the things that we don't really talk about a lot of, but I wanted to focus on this one because we're doing about office buildings, and a lot of times we go off engineering schedules, is the expandability and the collapsibility of our system. If we over design a system, we'll say like it's a 8-pack system, so roughly 40,000 CFM. That turns out to be 30,000 CFM. It's very easy to remove 2 fans out of the system to get your efficiency higher up, put 2 blank off plates on, and then have 2 spare fans on there. If for whatever reason they needed more capacity, or we design it, they say, well, we think it's 30, but it could be 40, we would do the reverse. We can make a wall that has slots for 8 fans, only ship 6, and then if they ever need to expand that system to 7 or 8, they can just add fans, plug and play. All the wiring harnesses are still there. And so they have the options to design a system bigger than they need to with the expandability of potential. One of the big options, and one of the stories that this was for a hospital in Florida. They were talking about expanding a building over the course of the next 7 years, another 3 floors. So the way that the bid was going out is they wanted to have all that equipment at one shot. And my concern in my talk to them was, instead of my competition by building you a 60,000 CFM array that's going to go into a building that has the 3 floors aren't even built yet, but you've got this giant system that's not really collapsible. We could build a system that is expandable over the course of your next 7 years. We'll build it for the first floor. We'll build it up to the 4 floors that you need, but we'll just add fans every time they commission a floor, and you're just adding capacity to your system. They like that idea, but they did end up going with it. But those are things that we can offer, and I think things that people should think about when they're talking about a project 7 years down the road that may want to add that capacity as they go forward. And this is where the low risk and high rewards comes in, is when repairs are required on this stuff, switching from AC to EC is not that big of a big change. You do get a lot more efficiency out of your system with EC. You eliminate some of the issues of the destruction part of a VFD. You get lower maintenance costs, improved cooling efficiency, more redundancy in a system, the less harmonics if you're looking at a 6 pulse to a standard EC. one of the things that people talk about with EC fans are harmonics. And the big key when we talk about those things is the differences in the drives that we're replacing. So things that we know about EC and some of the inherent deterrence to some of them is no different than comparing a 12 or an 18 pulse drive to a 6 pulse VFD. They're drastically different in how they handle certain harmonics and how they handle electricity. So they're not always the same apples to apples. So when we have those issues, we know where that conversation starts and how we can go and work with our partners to do that. With all of our engineering staff and all the partners that we do on our vendor side, we have solutions to answer all those questions and to give the end user as well as the mechanical contractor, as well as the rep in every facet of the sale, the confidence that what we're providing to them will function long-term in those solutions. And you can see just the old nasty double width, double in the blower with the old OSHA belt guard on there, and then what the new system would kind of look like in its place. Much more streamlined, much easier to maintain and install. And a lot of things that people tend to forget is that is a one kit solution. It includes your bulkhead, it includes your fans, it includes your wiring harnesses, all your sheet metal screws, your zip ties. Really, everything is there except the power and communication conduit between the disconnect and the fans themselves. And that's kind of where we roll into next with our EC integration. This is how a kit typically shows up. This would be somewhere between a 15 and 24,000 CFM system. You've got all your bulkhead pieces ready on a pallet with your quick connect box, and then all your wiring harnesses and screws and manuals or stuff in there. You've got your disconnect on your on its own pallet and your fans on your own pallet. Everything is labeled and easy to install and correlates back to the building sheet that comes with it. So it should be kind of snapped together relatively quickly. And our bulkhead wall is custom to the design space that you'll be working in. Normally we say it's true interior dimensions, floor to ceiling, wall to wall. We do take into account a little bit of play with our mounting bracket. So if you miss it by 1/4 of an inch, you're probably going to be okay. In the budgeting phase, we normally say you can use outside dimensions. But when it comes time to actually order the product, we need to make sure that those dimensions that you provide us are accurate, because we'll build it to that specs. So we don't want you to have a wall that's too short. Then you've got to have to worry about skinning pieces and the structural part. And we don't want a wall that's too big that you may have to cut down. All those clearances are pretty tight, and we want to make sure. So just take a tape measure, wall to wall, floor to ceiling. If you need the ability to put in a door, we have that capacity. If there's space provided, sometimes when you're removing a double width, double inlet blower, you lose that coil access that open space would provide you. So in the case that you may need a door because you're losing that access, let us know. We can add that cost into it, and the shipment will come with a door as well that we'll just install right to the bulkhead. Next one. We can also do vertical and horizontal mounting. A lot of systems you find could be up blast or down blast type systems. I don't tend to recommend laying a horizontal system for a down blast system, mainly because you don't want the fan. You need access to the fans, and they're going to be on the underside. But for an up blast system, the system can sit flat, and then you can, we may need some structure depending on the dimensions of the system, but they can be mounted in either direction. And when we talked about the wiring harnesses, every fan will come with the same connection points. And then you've got wiring that comes back that we provide. That'll be labeled fans 1, 2, however many fans there are, and they'll go to their dedicated wire routing. But we take all that account from the quick connect box to the fans themselves. They're just Molex plugs. They are not weather sealed. Typically, what I would say, if you're having any kind of humidity issues or outdoor air or moisture problems, silicone and dielectric grease could be a really good saver to make sure you don't run across any shorts. But there's no programming that's involved. You just plug and play these systems. We take care of all that addressing and all that stuff in our system. And it makes just everything a lot cleaner because you just disconnect those connections right there, pull that fan off the wall, put a new one back on, plug it right back in, and you're up and running. And this is our quick connect box. This is the power and distribution hub for all the fans inside the array. It mirrors some of the connections back to the terminal box outside, the disconnect box outside. So all your days, if you have more than this fan can hold, this quick connect box can hold 9 fans. If it's more than 9, we'll have 2 of those boxes. And they're just daisy chained back together. They all communicate back to the block. There's a fuse disconnect circuit breaker inside there with mini fuses in there. That tends to be the biggest point of failure in there. That's what it's designed to do, is to catch anything before it gets to the fans. So typically, if you do get a fan alarm, normally what I tell people is to check the fuses inside that disconnect is the first step to making sure that it's just, and normally we'll ship some fuses along with it, because it's very common if you get a high voltage spike or some kind of load change, maybe dirty power, that can take those fuses out relatively easy. So, but that's what like I said, that's what it's designed to do, to prevent you. It's easy to replace a $5 fuse in a multiple $1,000 fan. So, it has overprotection. The fans themselves have protection from them as well, which I think we talk about next. And it also includes your pressure transducers in there for mounting your on a premium controller for your high and low pressure. All of that stuff's inside that quick connect box. And then of course we have our control panel outside. This is the main touch point for most contractors and everything here. For a premium controller, you'll have that 7-inch Snyder touchscreen display, which will give you the CFM readouts, power readouts, static pressure, individual fan status alarms. It does have a hand auto and off switch, which is both on the premium and the basic controller. In the event that you lose 0 to 10, you can manually switch that over to hand mode, and there's a potentiometer right next to that you can dial in your speed for that particular array. Typically, what I tell people when they balance that system, when they install it, and they switch it over to automatic mode, whatever that voltage is that they need for their day-to-day operations, is to write that number somewhere on the screen or right near the potentiometer, so they know if in the event they ever have to go to hand mode for whatever reason, they know exactly where it is. The biggest problem would be was when we go back to that engineering talk between scheduled engineering and what the reality is. If we design a system for 50, 60, 70,000 CFM and your system's running anywhere from 10, 20, 30% less once it's balanced, if somebody were to come and take that potentiometer, turn it all the way up to 10, you're going to get that 50, 60, 70,000 CFM through old ductwork that may or may not be able to handle that kind of pressure. So it's a very big concern. That's why I normally tell them to write that on there. You can limit the RPMs inside the controller, but not in hand mode. So making sure that people know that this is the voltage we need to dial in if the situation arises is pretty important. And it has minimal landing points for the electrician. It's your 3 legs of power plus a ground, and then your 0 to 10 communication comes in. If you need to add anything else like safety and interlocks, start stops, things like that are all built into the control panel there for minimal landing. We do have BACnet MSTP. Right now we don't have an IP version, but I believe most people do end up having the MSTP protocols. So that's also that's standard on the premium controller. That would go to the next one. And this is kind of what a system will look like when it's completely done. This would probably be somewhere in between 40 and 60,000 CFM, depending on the static. So you can see the 2 quick connect boxes and all that conduit that you see between the outside disconnect and those quick connect boxes. Those are field installed. We do not provide those connections. We don't know where you're going to mount that disconnect in relation to the quick connect boxes, so we don't provide a whip option at this point. Plus, every municipality and state and city will have their own electrical codes, so making one whip that would satisfy everybody would probably be pretty impossible at this point. So we let the local contractors take care of the electrical part for making those connections. And still one of the best, if not the best, warranty in the business, with a 5-year warranty that covers everything. even our vendors don't give us 5 years on every component. We take a lot of that on ourselves because we've designed it well enough to know that it'll work. We've got enough engineering knowledge to be able to design that to go into your system properly. So it's very little that will fail outside of an outside source. It's very rarely coming from an application failure or a mechanical component failure from the manufacturer. And so we talk about lead times and installs. We've kind of touched on install time earlier, but right now we are sitting. I probably should have updated the date. I think we were sitting at 11 days at one point to design a system. That's design, build, from receipt of order. We can have the system built in less than 2 weeks. We have all the stock for everything. We build everything ourselves. The quick connect box, the disconnect, the bulkheads, the wiring harnesses, we do all of that in-house in our office in Florida, which is really good. Getting back to what we were talking about at the beginning with that unPAC Summit, where we're going to design that system. You can see every part of the factory that we build all of that stuff in. So we control all those touch points to be able to get that done. So it's great for retrofits. We also have expedited options, quick ship options for 24, 48, or even 1 week options, depending on your needs. They do come at a premium. But if something goes down and it's emergency, you let us know. There's always probably something we can do in most cases. And when we talk about Q-PAC as a whole, I would say that most of our systems are about 50,000 CFM or less. So 9 fans or less, which would be 1 quick connect box. We've obviously done upwards of 100,000 CFMs, 150,000 CFM systems. I think we've had a few 30, 40, and I think a 60 fan array done in different projects. So there's really no limit to what we can do. Really, we're kind of limited by space and static pressure. That tends to be about the only things that really kind of hinder how many fans we can fit into a space. But it normally takes a less than a 9-pack system, 2 or 3 people, less than 8 hours to install. Very minimal work from electrician side. They normally come in, make their landing points. In most cases, they're doing it over a weekend. So BMS may not be available to come in and land their stuff until an actual business day. But the electrician can come in, make his line voltage connections to everything. And once the fans have line voltage, you should be able to run the system in hand mode to at least get air going until BMS comes and lands their points. So it makes life a lot easier for the installing contractor when they walk away on Saturday, Sunday, or whatever the day they're doing it, that the occupants the next day won't even notice it. Next one.
This is a great chance for me to jump in and throw you a little bit of a curveball. So sure. I have a quick 1-minute video we can show you all, especially for people who have not worked with our systems before. This is a video sent to us by HTS New York. This is a project that they did where you can see them cutting out the old fan and then how quickly a few guys are able to install the full unit. This is exactly what we were talking about. It comes in kitted. It's easy to move through your access points, and just a few guys or a few gals or whomever can easily throw this in pretty much from one side, and it goes up really quickly. So you can see that was a 6-pack install. That was done within a day, just in an afternoon. It's a great little project for you all to kind of see how quickly this can be done. So talking about
this is
installs.
This is a pretty common size. I think 4 to about 6 or less does probably take up a majority of what we do. And once that's installed, they walk away, and then BMS will come in and land their points. And at that point, you don't really ever need to access the front side of that system. Everything will be done from the motor side. Very little that does fail. A lot of questions people ask about EC fans is, what their lifespans are. And they have SKF bearings. Their L10s are typically between 50 and 80,000 hours. So they'll have about 10% field failure rates, somewhere between 5.5 and 10 years. Their mean time between failure points are somewhere around the 100,000+ hours. So when we're looking at, we give you a 5-year warranty, even the 10% field failure rates tend to be after that 5-year warranty. So And as electronics and the winding process and everything gets better and better, we're now on like third and fourth generation electronics from these manufacturers. So they've kind of worked out all the woes of the first generation electronics where people were just learning about ECs. These things have been around for almost 20 years now, if not more. And so that technology has improved drastically over that time, very much like VFDs did when they first came out to what they are now. So ECs don't tend to be as big of an issue as they used to be. It's just different technology that is becoming more and more of a standard. So we'll talk about energy savings and ROI. It's kind of the last little bit of the system. And these were big case studies that we did. And we have some really good videos on YouTube under Q-PAC where we go over the U.S. Steel building. It was a massive case study. And so when we did this project, that particular unit, when I used that example of handling 14 floors, one blower wheel handled 14 floors of the U.S. Steel building in Pittsburgh. And there was a mechanical problem of one of those buildings' primary fans, and the repairs would have had, I think they said like 2 weeks or more worth of disruptions to the occupants, and it was just something they couldn't handle. And then they would have had to cut a hole in the side of the building and crane something in. And this was right around the winter time. So it really would have been a nightmare for them. And this was an optimum opportunity where they shut down the building on Friday when everybody left. They worked over the weekend. They had it up early on, I think, late Saturday night or early Sunday morning. They were ready to go and it was running. So when people came back to work on Monday, they were none the wiser. And they ended up reducing some of their energy usage by up to 66%, depending on when you're looking at their peak hours versus their non-peak hours. We did all their lean requirements or their lead requirements, and we gave them a maintenance-free solution. There's no longer a big giant blower wheel in there with bearings to grease and belts to change. So that was just a huge thing that we did a big video on that, and we were really proud of that building. And then we did another one for a major, I always say commercial plaza, but it was a massive headquarters for a large insurance company. And they had some other issues with their VFDs. The fans were really in a difficult location to get to and install. So this is just one of those ones where the client really needed something that could really handle what they needed without disrupting their entire building and operations. And I believe this was, I want to say it was 48 fans for this one particular giant air handler. And they ended up with like a 28% ROI, 45% of their savings on month to month. So HVAC is a huge drain on their HVAC system or on your electrical system. So if you can kind of improve that, you can get a lot of tax credits back from a lot of states and cities will offer that back if you can do some energy savings. So it's something to look into with your local energy supplier to see what kind of rebates they may give back to these companies to make those investments to try to improve their stuff. We can do some ROI calculators to kind of give them an idea of what their ROIs may be if they want to present that to the governing body that may award that. But things to look at when we're talking about these systems is not just the upfront cost of the actual equipment. It's really, when you're looking at labor to do something like our competition does with direct drive plenum fans, those systems normally take 2 to 3 times, if not longer, to install because those systems will come relatively complete. We will not say the name of the cubes that we're talking about, but they'll come complete and they won't fit through a standard doorway. They need to be disassembled and then brought back into the space, reassembled, gantryed, and put into position. And all that stuff takes time. And whether they're running it on one VFD or multiple VFDs, all of that stuff needs to be wired, programmed. All the motors need to be wired individually because they're not coming pre-wired. And all of that gives them an actual failure point more because all of that stuff has to be field installed. And while electricians are great, sometimes people make mistakes. And if you can eliminate some of that mistake process from them, you improve your chances of making sure startup goes even better. And then you're looking at from a maintenance cost. You still have bearings to grease on the regular. And Murphy's Law will tell you that if you have we'll just call it a 2x3 array with 15 horsepower motors, those things weigh about 400 pounds. It's always going to be the one on the top that fails. And then you've got to get rigging equipment and gantry systems to pull all that stuff out. So I always tell people, like, think about what you have to live with for the next 10 to 15 years of your life. If I can improve one standpoint of it, all of that stuff will save you time over the next 5-10 years. And sometimes that upfront cost doesn't always look so bad when you think about what's like to live with something. It's quieter in a lot of ways that they will never hear the fans. Sometimes the submittal data is a little weird because the fan manufacturers measure these fans at 3 feet inside the array. It doesn't take account distance. It doesn't take account any insulation of the panels that we're putting the unit in. So a lot of ways, for every 10 feet that you go from the exhaust of the fan, you're going to lose 8 to 14 dBs off that number. They're non-A weighted as well. So you'll have to take that into account, that A weighted numbers are even lower. So when we look at ECs as a whole, it's not just from an energy standpoint, there's also a comfortability and living standpoint from the redundancy level. So I know Mo's been handling the chat. I kind of can see a couple of answers in there, but we've got time for questions. If there's any questions you may have, no matter how complex it is, if we can't answer it here, we can surely answer it after the fact.
Yeah, this is a great time where I hope Charles is still on so that we can show him. Mo sent me a submittal that we can show just for you to cover really quickly. It's not a very good. I wonder if I can zoom in. I don't know if that gives people are able to see that any better. But yeah, so Charles was asking, he's an inspector, are there typical submittals that I can accept on several different permits for the same system? And Mo was saying that yes, submittals can be directly downloaded through our software, and Aaron may be able to show a typical submittal at the end of the presentation.
Yeah, this is just a submittal for like one system. Let's just say this particular job that we were showing the submittal for had 8 air handlers on there. It would list out all 8 air handlers. It would give you all of your electrical information here. Now, the submittals don't go into depth for the actual wiring process. That's all covered. In fact, the wiring diagram is the same for every system because it doesn't really matter. It really depends on how many quick connect boxes you have. So as long as, let's say you have 8 air handlers with all of them have less than 9 fans on there, the wiring diagram is exactly the same. There's only one terminal block in there that sends signals back to the quick connect box. So because it's a mirrored terminal, there's like your line voltage and then your control from this side to your line voltage and control on this side. They just have to connect those points back to back. And then we handle the wiring from the back side of that terminal block to the fans themselves. So for an inspector, your life's a lot easier. All you're really doing is checking, because we do all the inspections and testing before the systems go out to make sure all the communication lines are great and everything works. So really all you're inspecting is their line voltage coming in from the building to our terminal block inside the fuse block inside the disconnect, and then their connections between the terminal block in the disconnect to the terminal block inside the quick connect box. Short of that, the rest of that's all in Q-PAC. So it should make your lives on that standpoint relatively easy.
Great. And then we have another question from Doug. Doug earlier asked about being able to incorporate an access door into the bulkhead, which we answered. I don't know if you want to go more in depth, but then he asked just now, have you done any L-shaped bulkheads, putting an access door in the short leg?
So we've gotten creative before. In fact, I actually got asked yesterday to do a V design for a system. It's not to say that we can't do it. It really depends on the actual space and whether it's conducive to do so. Mainly because of when we have an angled piece like an L or a V, we have to worry about where those fans are in relation to each other. In our system, we designed them to work on a 2D plane, on a horizontal plane. So all the spacing is taken into account of how much space we need between the fans, height and width. When we start to bend that axis and then we start to go this way, we've got to worry about the 2 fans that are going to be closest to each other. What you don't want is exhaust, fighting each other on that side. So sometimes we may have to move the fans out away from that axis. And that will come into what we would call a special. So what we would do is we would design a system, and then we would give that over to our engineers where they would lay it out and they would make any adjustments that would be required. It's not to say that it can't be done. It's just it's going to be something very special and handled by our engineers.
Right. So yeah, there are a lot of things that we're able to make happen. You just have to kind of ask on the front end, and we pass it along to people much smarter than us.
And in most cases, yes.
So yeah, we have a few moments for a couple questions. If anybody's sitting around and has any more, I will remind you of our Impact Summit. So if you are interested, feel free to email that marketing@qpac.com. We would love to see you on the 18th and 19th. We'll have some keynote speakers from Zeal Abeg, from EBM Pabst. Our CEO is going to be speaking, Matt Kent, as well as our CFO, Kevin Van Dyke. You'll be able to see all the components in their station. You'll be able to see how they're manufactured, how they're put together. We're going to do a full system build and show you how quickly that can be done, answer any questions, and probably even let you all do some of the lifting if you want to, and see how quickly and how simple and plug and play these systems are. And like I said, some custom events. So we're going to have a lot of different networking events afterwards. We're going to have a lot of fun around St. Augustine. It's a great time to get out to the beach too. I don't know if you want to bring anybody along, but St. Augustine in October is always a good time. And then yes, Charles, so all the unpacks are available on our YouTube page. You can go into the live tab under our page and see them there, or there should be a playlist that says quick unpacks. So all of them are available. I also am the one who cuts them down, and I will be uploading a lot of micro content. So you'll be able to see 2 to 3 minute videos that sort of summarize each section. But the entire videos are there, and they are timestamped, so that if there's a particular thing that you're interested within that subject, you'll be able to just hover over the line at the bottom, and it'll tell you what section that you can jump to if you'd like. Paul, how can I get started in offering this to my customers? Hey man, I would love for you to just, again, email at marketing@qpac.com. That directly goes to me, and I will get you in touch with Aaron or Mo or whomever it is, and they'll be able to sort it out. Charles, yeah, thank you so much for joining. All those are available. If there's anything else I can do, really, that marketing@qpac.com is the best way to get in touch with us. And I will immediately get you in touch with whomever it is, and you'll probably be talking to them within a few minutes of sending that email. So yeah, if we have any other questions, we're happy to sit here for a couple seconds or a couple minutes and keep bantering away. But we thank you all for joining. This has been great. We love doing these. We do them every month. Next month, Aaron's going to be subbed out. We're going to bring Mo back in. We're actually going to be offering PDH credits in the next one. We're going to be offering a half-hour PDH credit, and that's going to be on efficiency. So Mo's going to cover a lot of different things about efficiency. Really excited for that one. We get a lot of questions about that. So that's going to be a great time to come. Invite your customers, invite anybody that you're working with who you think that this is beneficial for. This is not specifically for anybody. We are just open and available for any questions, for any content. And I will be sending a follow-up email after this. So if you have anything that you're interested in us presenting, any topics or questions that you didn't think of now, but you want us to answer later, that's a great place to just put those in. Again, those all go directly to me, and I'll make sure that we get you answers quickly. And we make quick unpacks that you all are interested in coming to attend. So I'll quit talking now, leave the floor open for any questions. We'll sit here for probably about 30 more seconds if we don't get anything else to pop in. That is not good.
That's an old one.
Yeah, it was an old one.
No, but you can watch. Yeah, you can watch that hospital unpack on our YouTube channel.
Yeah, the last couple series where we did hospitals, we did universities, we've done office buildings. Before that, we did acoustics. We have done just a general overview, harmonics. I'm blanking on some of the other ones, but Mo and Kurt have done a great job presenting. And excited to have Mo back in. So. Well, thank you for joining us, everyone. We will talk to you next time. And again, marketing@qpac.com if you have any questions, if you want to get in touch with any of our salespeople, any of our engineers, and we hope you register for Impact. So we'll talk to you all soon. Thanks.
Thanks, everyone.